Okay, hello everyone. So I'm going to go over the 3 EKGs that we gave you as a PDF. This is not meant to teach it to you. This is just meant really as a review. So if you don't understand the concepts, go back and watch the initial videos that go through all the individual steps on how to read an EKG. And if you still have any problems, please email me. I'm happy to go through it with you. Because if you have a question, I bet you other people do too, and then maybe we just need to clarify that. All right, let's go to the first EKG. Okay, so here we are at the first EKG. Remember, what we're going to do is rate, rhythm, axis, intervals, ST segments, and T waves. So we call those injury patterns. What I did not mention on here is hypertrophy, and there's a whole bunch of other things. Look, reading EKGs is a career-long skill that you're going to develop. You're only going to go through the basics here, so don't worry if you don't get it all. It takes years to nail this stuff. Okay, let's look at the rate first. Right, so we know there's a couple of ways of calculating rate. The first way is to count all the QRSs, and we have 14 of them here, right? And so we know that this is a 10-second strip, so we know that 14 times 6, because we've got to get 60 seconds, right, is about 84. Right? That's the first way to do it. The second way is to count the boxes between two RR intervals. So let's find one that's kind of close to one of the big lines, and I think this one will have to do. It's close enough. And so we know it's going to be 300 divided by the number of boxes, right? And so let's just say it starts there. Okay, so 1, 2, 3, 4. And so this is 300, 150, 100, 75. And so we're somewhere between 75 and 100, and we're maybe closer to 75, so somewhere around 80, right? And that kind of jibes with what we got over here of 84. So for our rate, let's just put down 84, and that's normal. It's not too fast, it's not too slow, right? Because it should be somewhere between 60 and 100. Rhythm is the next thing. So let's take a brief pause and take a look at this video here, this drawing here. And so you can see this is the conduction system of the heart. We have our SA node where most signals will start. They travel down these pathways here to get to the AV node where it pauses for a few seconds, not few seconds, milliseconds. It pauses, and then it goes down this Purkinje system, right? So that's the typical way that a signal will propagate, and that's what we call the rhythms. Where is it coming from? Where is this rhythm starting? A rhythm that starts in the sinus is called a sinus rhythm. A rhythm that starts somewhere above the ventricles are called supraventricular rhythms. The ones that start in the ventricles are called ventricular rhythms. And so that's what gives us this typical waveform of sinus rhythm. The P is when the atria are depolarizing. This pause here of the PR interval is this pause in the AV node. Then it goes down this superconducting fibers of the Purkinje system that gives us that very narrow QRS. And remember, time is along this axis, so it's the longer something takes, the wider it'll be, and this is narrow because this is fast, right? Then we got our T, which is our depolarization of the rest of the ventricles and stuff. All right, let's look at an example here. So let's say that a different starting point. So instead of starting in SA node, it's starting from multiple different parts in the atria. And this is going to be called something called atrial fibrillation, because it looks like the atria are fibrillating or shaking or quivering, right? And so this one takes a little bit of time to get here. This one has to take a longer path, so it takes longer to get there. This one takes even longer. This one's also pretty short. So once it finally gets here, though, it can go through and have your narrow QRS. So this one takes some time to get here. Then there's and the other thing is there's no organized depolarization of the atria. That's why you don't have any P waves. You get just wavy little jumbly line like that. So narrow QRS, then this one fires, then maybe this one goes next, and so the space in here is small because it rapidly reached there, so you get that one. Then this one took longer, maybe it's coming from here. Then that one took a long time, it's coming from there. So you can see that it's irregular. In fact, it's irregularly irregular. So there's no P waves with atrial fibrillation. You see this wavy thing because we don't have organized depolarization of the atria, but we do have narrow QRSs because we are using the Purkinje system, which is fast. Let's look at another one here. Let's say that we have this as our foci, however you say that, of depolarization, right? It doesn't have any fast fibers to get there. It's got to meander slowly through here till it hits one of these and goes through super fast. So again, slowly, so that's why it's Y. Then it hits it, boom, and it's fast. Slowly, and then it's fast. Slow, then fast. And so this kind of wide QRS that we're seeing there, that's pretty indicative of some sort of ventricular rhythm, assuming there's no SA or AV node, there's no P waves or anything here, which is how I drew it. So let's go back to our EKG from before. Okay, so let's just look at one of these. When we look, we have a P, we have your typical QRS here. Even though there's no Q or S visible here, we're calling it the QRS complex there. T, P, there's a little Q right there, right? R, no S, but we'll still call it the QRS, T. And we got that same pattern going everywhere, right? So a P for every QRS, a QRS for every P. They appear to be marching out pretty regularly. That looks like a normal sinus rhythm. So let's mark that over here. Normal sinus rhythm. Let's do axis next. So if you'll remember from our previous videos for axis, we have to create a Cartesian coordinate system, right? And so this is where positive AVF is pointing, right? Because it stands for foot, so it's got to be pointing down. And then this is positive 1, all right? And so the other axis that we really need to take account of is a line over here, which is not any one of our leads, but we do have a lead that's perpendicular to it, exactly perpendicular to it, and that is lead 2. So let's take a quick look at this now. Anything that is in this zone over here, ooh, that's too green. This zone over here, we're going to call that normal. Anything that is in this zone over here, we're going to call that right. All right? Anything that's over here, we're going to call that extreme. And anything that's up in here, we're going to call left. Now, what about this zone over here? That is also normal, because that's just how people are built. Most people will have their axis somewhere in between here. So if 1 is positive and F is positive, 1 is positive and F is positive, we have normal axis, right? If 1 is positive here and if F is positive and 1 is negative, right, then we have right axis. So now if we have F is negative, right, and 1 is negative, then we have extreme axis. And finally, if we have 1 being positive and F being negative, we're in this no man's zone over here, and we need to figure out, are we actually in left axis zone or in normal zone, right? And so how do we do that? Well, we look at this lead over here called lead 2 and the lead and this line that divides it. We know that if we're on this side of that line, we're in the normal zone, right? And if we're on this side of that line, we're in the left part of that. And so how do we tell? Well, you can look at 2. If we're going in this direction, then we know that 2 is positive, right? If we're going in this direction, then we know that 2 is negative. Okay, watch the other video for more details about that, but let's take a look at it here and see. So the way we look is, let's look first at 1. And this is our line of 0. Okay, and we look at this QRS. Is most of it above that line, meaning positive, or below that line, meaning negative? Most of it is above that line, so I would call that positive. Now you can count individual boxes if you want, and subtract off those that are going underneath versus those that are going above. I'm just eyeballing it, and it looks like most of it's positive here. And if we look at F, same thing here. This is that line of 0, right? And most of it's positive there. So I'm just eyeballing it here, and I'm going to say we are in the 1 is positive zone, the F is positive zone. We are in normal axis. So let's record that up here as well. Axis, normal. Now let's look at intervals. And maybe we'll just come over here. Right? And so we know that this is where the start of P is, right around here. And maybe the start of R there. So we have the PR interval is our first one. And PR should be somewhere between 120 and 200. It can't be too long, and it can't be too short. So we know that each one of these big boxes is 200 milliseconds, right? And each one of these small boxes is 40 milliseconds. So how many do we have here? It's hard to see, but 1, 2, 3, maybe 3.5. Let's say it's 3. Okay, so 3 times 40 is 120 milliseconds, which is good. We're in the normal. Now let's look at the QRS. Let's look over here at this one. Okay, And so it looks like it starts about here. It's 1, 2, maybe 3, maybe 2, 3-ish. So let's say 2. And the QRS we know should be less than 100, or some people say 120 milliseconds. And so 2, let's say 2, okay? So 2 times 40 equals 80 milliseconds, which is less, which is perfect, right? We want this to be nice and narrow and fast because we know that that's the speed going through that His-Purkinje system. The last thing we can look at is the QTC. Now that one's a little bit harder to do. Okay, so the QTC really is this distance here between the T and the Q. And it requires a little bit of mathematical formula. So you take the QT, divide it by the RR, and that gets you the QT corrected. And you have to do this thing 9 times and take the average, which we are not going to do, right? Because that's crazy. Instead, we're going to eyeball it. Because you're going to look at the computer, and the computer is going to tell you what the thing is, what the QTC is, and you're going to use that, because who's going to do 9 square roots? But one thing you can do is the bisection method. Draw a line through one QRS and another QRS and a line right down the middle. All right? If we are on this side over here, that means we're on the good side. It means the QTC is probably less than 500 milliseconds. If we're on the other side, the QTC is greater than 500 milliseconds. Well, what's normal? I didn't tell you that, right? The QTC, and the reason we have to do this correction is because it is very rate dependent. And it's different for men and it's different for women. And it really, depends then on what you got. But really, even though those numbers are there, you really start getting into trouble when it gets above 500 milliseconds, which is why I think that this bisection method works. Really, you're going to look at the top of the EKG to figure out what is the interval. So the intervals are all normal. So let's put down here. We had a PR, normal, right? The QRS, normal. And the QTC, normal. Then injury patterns, that's the last thing. So let's do a quick look at a heart. So let's say this. So let's try to take a look at this heart and divide it up by different geographical distributions. So this here, it's the bottom of the heart. So we'll call that the inferior part of the heart, right? Let's say that this over here is the left side, but we really call it the lateral side because the heart sits in the left side of the chest, and so it's lateral. And I might even call this up here the high lateral side, okay? And then up here, maybe we have the anteroseptal part, which is in front. I know that green is hard to see. And something that we're not going to really talk about, this is obviously going to be the right side. So where are the different leads that are pointing to this? This is what we want to know. So if we look at the inferior leads, what's pointing to the bottom? Well, F, which is coming from the foot, right? 3 points to over there, and 2 points over here. So what are the inferior leads? Well, it's 2, 3, and AVF. What's looking at the lateral part? Well, we know that 1 is kind of looking over here, and L is looking over here. And so 1 and L, I call them the high lateral leads. Yes, AVR is over here doing its own thing. We're going to ignore that guy for now. Let's look now at the precordial leads. If you imagine that we're drawing a plane through the heart, so you can see that it's like a cross section here. Now we know that what's looking at the anterior part? Well, we have V1, V2, V3, 4, 5, 6. These are approximations, my drawing. They're not exactly perfect. You can watch the video to see exactly where the leads are. But what do we know? We know that what's pointing at this anteroseptal ones, V1, 2, and 3. What's looking at the lateral leads, V4, 5, and 6. Now let's do this looking at the EKG. So let's first look at the inferior leads. Okay, so we said the inferior leads are 2, 3, and F. So these are the inferior leads. So if you see any ST elevations or T-wave inversions, both are kind of some injury patterns, you would look for them. If it's going to hit 3, it should probably hit 2 and F as well, because they're all kind of pointing to the same area. Now, let's look at the high lateral leads, or actually just the lateral leads. These are the lateral leads here, 1 and L. Okay, but also we said that these are kind of lateral leads. I'm going to lump them all together. I'm going to make some approximations here, so we're not going to lose some of the detail here. So these I'm going to call the lateral leads, And then that leaves these in the center, which we're going to call the anteroseptal leads. So again, if we see ST elevation like that, right? That's what we would see. If we're going to see it in the lateral leads, we would look over here, and we should see them here, but we should probably also see them over here. If we're going to see some ST elevations in the anteroseptal area, we would probably see them in V1, but also V2 and V3. If we saw something in 3, we should probably see it in F and 2 as well. Now here, so this is the way I look at them too. I group together. First I say, any ST elevations inferiorly? No. Any laterally? No. Any anteroseptally? No. R, also fine. How about T-wave inversions? Any T-wave inversions? Yeah, there's one here in 3, but not in 2 and F, so it's an isolated one in 3. I don't know what to make of it. These are non-specific changes. I'll put that in the back of my head, but it's probably normal. Anything in the lateral leads? No. And no. And anteroseptally? Again. Sometimes you can see this flipped one here in V1 and it's normal, but its neighbors, they seem to be up. So I'm going to say up here that our T waves, no T wave inversions, right? And no ST elevations. And so that's the EKG, right? We have it now. We got a rate of 84, rhythm normal, sinus, axis is normal, the intervals were normal, and there were no injury patterns that we saw. All right, I'll see you in the next video.